On this one, they tell us segment AB is perpendicular to segment BC. What's perpendicular mean?
Forms a right angle.
Forms a right angle. Let me get this set up here so I can get a pen. So it forms a right angle. As soon as you see that symbol, that's what you should think of. Right angle. So AB is right here. BC is right here. What do I know about that angle right there?
Right angle.
It's a right angle, so we can mark that. Segment AD is perpendicular to segment DC. So what do I know about this angle down here?
Right angle.
It's a right angle. Somewhere in our two-column proof, we're going to have to say something about right angles. All right? Once I know that this is a right angle, that's a right angle, we had a theorem that said what about all right angles?
They're the same.
They're the same, they're congruent. We had that theorem. So we should be able to prove that those two angles are congruent to each other. Come out here, write my statements and reasons. Statements, reasons. If I start writing in cursive throughout the two-column proof, please tell me to stop so that you can read it. But I mean, you can read statements and reasons, right? And you know what goes there. What's our first statement going to be?
Given one. AB is perpendicular to BC.
Segment AB is perpendicular to segment BC. A lot of people still putting both those given in the same step. Don't. Separate them. So if you got that written down and you got them in the same step already, mark it out and redo it. How did we know that?
It's given.
It was given to us.
It's segment BC.
Sorry, got it. Thank you. Now, once we have that, once we knew that this segment was perpendicular to this segment, what did we say next? That was a right angle. What angle is that? It's angle ABC, right? But we look here, and the book was lazy, or whoever made up this problem was lazy, because they didn't name it ABC. What did they name it? Is it all right to name it angle B? Yeah, because there's only one angle at that vertex. So angle B is a, sorry I wrote in cursive, right angle. Angle B is a right angle. That's what you write down next. This is where a lot of people get confused because you had to come up with that on your own, right? But what's going to lead you to that, as soon as you know you had perpendicular, it's right angle. So it's not given, right? Because this told us perpendicular, but we got to know what perpendicular means to get to this. Well, what does perpendicular tell us?
90 degrees.
That they form right angles, right? And that's what you write over here. Perpendicular lines, form right. And believe me, I don't like writing any more than any of the rest of you. Perpendicular lines form right angles. And I simplify things down as much as I possibly can. But that's about as far as you should take it. Perpendicular lines. A lot of people are putting perpendicular angles. No such thing as perpendicular angles. You can't have two angles and they form a right angle when they cross each other. All right? Lines can form a right angle. Angles can't. Where are we going to go to right after that?
Angle AD is perpendicular to DC.
Say it again.
Segment AD is perpendicular to segment DC.
How do we know that? That was given to us also. Use a little common sense now. Where do you think you go next?
Angle D.
Getting all this, Chloe? Quit coloring in the picture and pay attention. No, she's not. She's not paying attention. I'm getting ready to stop and it's going to be a quiz grade. I'm dead serious. So angle D is what?
A right angle.
Is a right angle. How did we know that angle D was a right angle?
Give it. No.
Say it, chicken. Perpendicular lines form right angles. Anytime you have perpendicular lines, they form right angles. We knew that, that's why we said this here, we knew that we had perpendicular segments or lines, well then that told us that we had a right angle. Now what'd you guys tell me about right angles?
They're the same.
They're the same, they're what?
Congruent.
Congruent to each other. So what's our next statement gonna be?
So right angles are congruent. Angle B is congruent.
Angle B is congruent to angle D. That's what we're trying to prove, isn't it?
Oh, yeah.
How did you know that if this was a right angle, this was a right angle, then they had to be congruent to each other?
Because right angles.
We had a theorem, right? What'd that theorem say?
If there are two right angles, something like that.
All
Right angles are the same.
right angles, quit saying the same. All right angles are what?
Congruent.
Congruent. All right angles are congruent. A lot of people wanted to put in here, since these were perpendicular, angle B was 90 degrees. Could you have done it that way? Yeah. Then you'd have to say angle D is 90 degrees. And then your reason down here for this could have been something a little different. Could have been they have the same measure, so they are congruent to each other. Again, this is just, these two column proofs just gonna take you step by step. You say something in statement one, what was the key idea in statement one?
Perpendicular.
Perpendicular. As soon as you see perpendicular, what should you think of?
Right angles.
Right angles. That's gonna be the key idea in the next statement. That you just lead yourself through there. Now, we could have, once we said right angles, you could have had something in statement three here about, once you know it's a right angle, then what do you know about it? 90 degrees. This time we didn't need that. Sometimes, you know, there'll be extra information that you don't need to put in there. All right, looking at the next one. This new book likes to do this. They put a bunch of pictures that look like real life things in there. They tell us angle 1's congruent to angle 4. So I'm just going to come in here. Angle 1 is congruent to angle 4. What's those little arcs tell us?
They're congruent.
Congruent. So those two angles are congruent. That's all the given information. Do we know anything else in that picture?
Angle 1 and 2 are vertical angles.
Angle 1 and angle 2 are vertical angles. So what's that tell us about angle 1 and angle 2?
They're congruent.
They're congruent. Vertical angle, we had a theorem that said vertical angles are
Always congruent.
always congruent, or are congruent. So we know angle 1 and angle 2 is congruent. So how would I mark angle 2 here? Just put one arc on it, just like angle 1, right?
Oh, yeah.
What's that tell us about angle 2 and angle 4 then?
They're the same.
They're the same because they're marked the same, aren't they? What are we trying to prove?
Angle 1.
Angle 2 and 4 are congruent. Well, we just sort of did it. Now, what do we know about angle 3 and angle 4?
They're vertical angles.
They're vertical angles also. Do we even need that?
No.
Nah, so that's extra information that we don't really need. Statements, reasons. What's our first statement gonna be?
Angle 1 is congruent to angle 4.
Angle 1's congruent to angle 4. How'd you know that? That was given to us. Can we say anything else about angle 1 being congruent to angle 4? That doesn't lead us to anything else. We can't say that they're hippopotamus angles or anything crazy like that because we don't know that, right? So that doesn't lead us to anything. So then we gotta come up with something on our own. And what did we come up with on our own?
That angle 1 and 2 are vertical angles.
Angle 1 is congruent to angle 2. Evan keeps wanting to mix up his statements and reasons and put them all in one thing, right? We can't do that. And how did we know that angle 1 and angle 2 are congruent?
Vertical angles.
And this is what you gotta write every single time. Vertical angles are congruent. That's what we write. Don't explain it out with angle 1 and angle 2 or any other angles in there. You're just wanting some generic thing that tells us everything that you need to know about vertical angles. What do we know about anytime you have vertical angles? They're always congruent to each other. They're always the same. Now look at what we have here. We know angle 1's congruent to angle 4. We know angle 1's also congruent to angle 2. Well, if I know 1 and 4 are the same, in place of 1 right here in this second statement, what could I put in? Angle 4, right? Now that's going to be backwards to what we have here, so I'm going to turn it around. So what would I write? Angle 2 is congruent to angle 4. What property did I just use there? Substitution property. Again, a lot of people want to put the fact that angle 3 and angle 4 were vertical angles in there. If you put it in there, is it wrong? No, it's right, but does it help you get to where you need to go? No. That's all of this one.
Could you use that as more points?
There's only, no. No, because then you could do something like this. Let's see, what could we put? We could just put something crazy in here and put
You could like switch all of them.
quad, A, B, C, D, and write given over here, and then put A, B, C, D has 4 sides, and A, B, C, D has 4 angles, and that's all stuff that's true, but does it have anything to do with this problem? Don't write that down, in case somebody's not paying close attention. Curtis was paying attention to that. Last one. This one. Now, I think I told you guys, it said solve it, but we wanted to write a 2-column proof, right? Still had some people that didn't. That's not a hurt. What's our first statement going to be?
Excuse the interruption, but can we have Josh Cook to the office, please?
What's our first statement going to be?
-4. Parentheses, -3x minus 9. Equals 12. Yeah.
Now let's give it to us.
Sure.
That's going to be our reason over here, right?
Yeah, sure. Perfect.
Distributive property. If you want to abbreviate distributive a little farther than that, that's fine, because it doesn't mess anything up. What do we get? And some people even came out here and worked the problem out here so that they could see it, because you really don't want to work in the 2-column proof. All right? What do we get when we use distributive property?
-12x.
Negative times negative. Positive 12x.
Plus 36.
Good, plus 36. Negative 12's still here. A lot of people got confused right here on that 36. You gotta remember that you gotta distribute that -4 out to both of them. And the other thing that people got confused on is the negative times the negative is a positive. They put a negative there, and then that messes up the rest of the problem. Now what are we gonna do next? Subtract 36, so Evan's telling us the property first. We're gonna do subtraction property of equality. Subtraction property of equality. Remember, anytime you do something, both sides of the equal sign, it's gotta have that of equality on there. So we subtract 36 on both sides. What's left on the left-hand side?
12x.
How about on the right-hand side?
-20.
I heard 2 different answers.
-24. Isn't it? No, it's
A lot of people made that mistake too and put 24 here. You're subtracting 36, right? So you got a -12 and a -36. That gives you a -48. Notice again, on this quiz, because I'm doing it for you, if you don't number your steps, they're wrong. Because I said that at the beginning, right?
So this is really quick, right?
Yep.
How many points is that?
I don't know, how many points is that more? 6 points, right?
6.
What's the next step?
Okay.
Division property of equality.
Okay, so our reason is gonna be division, property of equality. What's x equals -4. Lexi, that help any?
A little bit.
Main thing, and I remember on Curtis's test, I even wrote down, even though, not saying anything bad to Curtis or anything, but even though he missed like a whole bunch of one of them, he tried. And when you try like that, you never know because you can't tell the way I grade, right? Nobody ever knows. But so when Curtis tried, I done threw in an extra point for him here or there. Because he actually wrote it down instead of a lot of the tests I got had that written down on it and then they
I
quit.
seen that on some of the homework that I was reading yesterday.
They put that down and they quit. Well, don't think I'm giving you any extra, right? Curtis got a bunch of extra stuff written down here. Ain't none of it anywhere close to right. But I still might have threw an extra point his way because he attempted it. Okay? Alright, make sure your names are on those. You're going to lay them on that table right up there. Then you're going, when you get back to your desk, you're going to open up your books to page 123. 123. You wait. Spit on the shirt. What? Spit on the shirt.
Got it.
Oh, no. That's King Louise. No. I actually don't like this one. What's your favorite team?
Big Patriots, that's what I thought.
Yeah, the Patriots got beat by the Cowboys. That's it.
The Cowboys.
When was the last time you were in Pittsburgh?
When was the last time you went to Cincinnati?
A couple days ago.
No days ago? I was in Pittsburgh a couple years ago.
I was in Cincinnati yesterday.
You want a cookie?
We live about,
Where you got? Where you got?
about 25 miles from Cincinnati. I actually live closer to Cincinnati than I do here.
Well, then you got a
So
problem.
then you might want to
Why
go
do you
to
drive so
Cincinnati.
Why do you trouble? You live so far away. Right.
Page 123. Problems. What was it? 1 through 10, right? Books open. Follow along. Make sure you understand this. I'm not going to do anything with that homework, but I do want to go over it. It's stuff that you're supposed to remember from algebra. I believe this is number 1. They said find the slope. Isn't that what they said? Find the slope? So if we just pick 2 points, it looks like, help me out on your graph because my graphs may be wrong.
3 -1.
Does it look like it has a point right there? 3, -1?
Yeah.
And then 1 right here?
-1, 2.
How do we find the slope if we know those 2 points?
Right there.
Rise. How much rise did I have there?
3.
3. Now be careful with your run. How much run did you have? Close.
4. 4.
It's going to the left, so it's got to be a negative, right?
Oh, okay.
So, and remember, what stands for slope? What letter? M. That would be your slope. Next one. Is this point right here one of them?
You're a bit too high.
I'm too high? Is it this one?
Over to you.
Is that one there? Then maybe this one? Is that the one? How much rise? Mine looks like 3. Is it supposed to be something different? Goes up 3.
4.
How much over? Now you could reduce that down and just
those 3.
make it 3. That'd be your slope. Kind of, what's special about this line? All lines are straight. Don't tell me that.
You just gotta count.
It's horizontal. Thank you. This is a horizontal line. If it's a horizontal line,
And you go 0.
what do you you know about the slope? 0. What if it had been a vertical line, which they didn't give us one this time, but
They just straight up wherever it is.
that's true. But what's the slope then? There isn't one, no slope. Vertical lines don't have a slope, horizontal lines have a slope of 0. Any other diagonal line has a slope of whatever the rise over the run is. Next one, we want to write these equations. This is something we're going to get into later on this chapter, but they wanted to try to refresh your memory. On the equations, you should have learned 3 different forms last year. You should have learned slope-intercept. Anybody remember slope-intercept? Y equals mx plus b. That's the one that everybody always remembers because that's one used the most.
If you have like one of the questions on the test, like if it was like vertical, what would you put for the answer?
No slope. If they ask you for the slope, you just put no slope. Or, what else? Yeah, no slope is the best thing.
No solution.
Yeah, you don't really want to put no solution because no solution means there's not an answer. And the answer for that one is it doesn't have a slope. So y equals mx plus b, that's slope-intercept form. Another form you probably learned, ax plus by equals c, that was called standard form. And then the third form that you learned that nobody ever likes, but is probably the most useful form, is y minus y sub 1 equals m times x minus x sub 1. And that's called point slope form. And the reason it's called point slope form, because you have the slope there, and you have some point that falls on the line there. If you plug in those 3 things, you'll have an equation for the line. So when they give us this information, this one here is the easiest to plug in and find the equation with. So if they just want an equation, all I'm going to do, what am I going to put in place of y sub 1 here? What's our y coordinate? 1. What am I going to put in place of m? Negative 3. What am I going to put in place of x sub 1? 6. That's your equation right there. You could just leave it that way. All right? Now, they tried to show you how to do it using slope-intercept form. And that's fine. You could use slope-intercept form. So we could use this form. We know the slope. So we could just write in y equals negative 3x. The bad thing is we don't know the b. Well, you can find the b by using this form and plugging all this stuff in and leaving b as a variable. So we plug in 1 equals, and this is what the example up above showed you, 1 equals negative 3 times 6 plus b. What is negative 3 times 6?
Negative 18.
Negative 18. Add 18 to both sides, what do you get?
19.
So that would be our b.
Yeah, that's what I was talking about.
That equation, those 2 equations, even though they look completely different, exact same equations for the same line. Just 2 different ways to write it. Let's go with this one on this one. Tell me how to write it. Y minus what?
Negative 4.
Y minus negative 4. What's that going to do to this?
So, add.
Make it plus 4. What's in place of m?
1/2.
Times what?
X minus 2.
That's a good enough equation. If I ever asked you to just write an equation, you could leave it that way. Now, the bad thing with point slope form, you can't really do anything with it. If we use our calculator, if you have a graphing calculator or you want to graph it, then we need it in slope-intercept form. So we'd have to change this over. And we're going to learn how to do that later on in the chapter. Still with me, Kenneth?
Yeah. Yeah. Sure, that's not right.
No, you can't because reason way set up for me. If we look at this one, instead of using this form, I'm going to use the slope-intercept form because you have something special right there, that 0, 9. If I was to graph that, where's that going to fall on the graph? On what? It's going to fall on the y-axis, isn't it?
Vertical.
So it's gonna fall somewhere like up in here. Well, that number right there is your y-intercept. It is your b. If your x is 0 here. So if I go to write it in slope-intercept form, what goes in place of m?
2/3.
2/3. X stays the same. What goes in place of b? So plus 9. Now that only works, that wouldn't have worked for either one of these two. That only works if that x coordinate right there is 0. That's the only time that works. But if it does, then we can write it in slope-intercept form real easy. All right, flip over to page 124. On page 124, they wanted you to solve these by graphing them on a calculator. If we were to graph these on a calculator, what would end up happening is you would have some line that looks like this maybe, some line that looks like this, and your solution is where the two cross at. Right? So, I didn't want you to graph them because the form that these are in, there's an easier way to solve. If they were in if all of them were in slope-intercept form, then that's probably the easiest way to solve them. Grab your calculator and just graph them and go with that. All right? When they're in this standard form, the easiest way is to use the elimination method. And you also did this last year. Elimination, can't spell. Elimination method. And all that means is you're going to try to eliminate one of the variables. To eliminate one of the variables, what you do is you get them to be opposites of each other. Alright? When I'm looking at this, what I would do in this case is I'd get the y's to be opposites, because one of them's already a positive and one of them's a negative. All I got to do to get these to be exact opposites of each other, this one's a 2, that one's a 1. Well, what do you got to multiply 1 by to get it to be opposite of that 2? 2. So I'm going to multiply this whole equation by 2. What's 2 times 2x?
4x.
What's 2 times negative y?
2y. Negative 2y.
What's 2 times 4?
Can't you just subtract it?
Now, I'm going to rewrite this equation down here. And now all we're going to do is add them straight down. What's 4x and x give you?
5x.
What's negative 2y and 2y give you?
0.
What's 8 and 2 give you?
10.
What's nice about this new equation? It's easy. It's just got x's in it, you can solve it.
X equals 3.
Divide by 5, x equals 2. Once we know what x is, now can we go back and find y? Yeah, you just plug it into one of these. If I put 2 in right there, I'm going to subtract 2 on both sides. End up with 2y equals 0. What's y equal then? If 2y equals 0, divide by 2, and what's y equal? 0. So that's the point where those two lines cross at. All right? Question?
Instead of like times it, can you subtract it to the bottom?
You can't, it wouldn't do you any good to subtract them, because x minus 2x would give you negative x. 2y minus another y would give you 3y. You still got x's and y's in them. So you have to times them first to get them to be opposites, then add them or subtract. If I do this next one, pick a variable, x or y. We do the y's. What do you got to do to get this 2 to be opposite of that 4? Times it by what?
2.
Just 2?
Yeah. 4.
Negative 2, right? Why negative 2? Because that's going to make it the opposite, right? So we times negative 2 times x, that gives you negative 2x. Negative 2 times 2y gives you negative 4y. Negative 2 times 2 gives you negative 4. We add these straight down. What's 2x and negative 2x give you?
0.
0. What's 4y and negative 4y give you?
0.
0. What's 4 and negative 4 give you?
0.
Well, everything canceled out. And what that tells you is that these two lines were the exact same line. So if you were to graph them on your calculator, it looked like this. The calculator would do that, then the calculator would do this, and it'd be the exact same line. So that when you end up with 0 equals 0, that means every number will work. Every number is your solution. Let's look at the last one. I just want to do this last one. I think this is the one I want to do. I'm looking at this. Pick a variable, x or y. X. How am I going to get those x's to be opposites?
Negative x.
Just change the sign, right? So all I'm going to do here, change the sign of that, change the sign of that, change the sign of that. Then I can just add them straight down. What happens to the x's? 2y and y give you 3y, 2 and 4. Solve, what do you get? Y equals what? 2. Once you know y, we take it back up here and plug it in. X plus 2 times 2 is 4 equals 2. What's x going to end up being? Negative 2. Good. That's not the one I want to do. I must have wanted to do this one. How am I going to pick a variable, x or y? X. I heard Bree say y first. What am I going to do to get these y's to be opposites? Negative. Just change the sign of everything again, right? Change that to negative, change that to positive, add them straight down. What happens to the x's? 0, 0, 4. You end up with 0 equals 4. What's that tell you? Is that the same as this over here? This over here told us that those lines were going to be the exact same line. This time, what it's telling us is instead of being the exact same line, it's going to be another line that looks like this. What kind of lines are those? And that's what we're going to talk about today. Where are those parallel lines going to intersect at? They're never going to intersect. So what's your solution here? No solution. No solution. Or you could just put that symbol down. Maybe you remember that from algebra, called the empty set. On your test, hopefully at the end I'll have time to let you see your test. You can't keep them today because still a lot of people haven't taken them. New 9 weeks. New 9 weeks. So on your binder, start it off right, do it right. It should be easy, right? You empty everything? No, leave everything, just leave everything in there. Add to it. So this is going to go in your notes section of your binder. So Curtis gets his out. He's got a piece of paper in there. He writes it down right in there. Is it ever going to leave there? No. Pairs of lines and angles. Paper. I think I got some paper up there. You can borrow some loose paper. Just write the title down. I'm getting ready to switch it. Pairs of lines and angles. What we're going to cover today. Identify parallel perpendicular lines. We already know what perpendicular are. What's perpendicular mean? Right angles, 90 degrees. Identify pairs of angles formed by them. Solve problems using those the properties of parallel lines. All right, write down these 3 definitions. These are the 3 different kinds of lines. Give you about a minute. Copy them down. This is the symbol for parallel. You already know that that's the symbol for what? Perpendicular. Skew lines don't have a symbol. Curtis knows when he gets out here and he writes lines that intersect at right angles. Can he use that angle symbol in there in place of angles instead of writing that word out? Yeah, go right ahead. As you go down through this, what's coplanar mean? Same plane. What's non-coplanar mean? Not on the same plane. Just some of the terms that we had earlier this year. Make sure that Chloe knows that she can't just forget all that stuff. Not history class, right? All the stuff that you learned in chapter 1, chapter 2, you need for chapter 3, chapter 4, chapter 5.
She's easy though.
These are easy. Anybody ever heard of that last one? Skew lines? Some of the middle school teachers started teaching it, I think about 5 or 6 years, 7 years ago. Parallel lines, what would parallel lines look like if I had these two? How would I have told? Alright, so that they're never ever going to intersect each other. But they have to be what to each other? They got to be on the same plane. Perpendicular lines. Something like this. What do we know about this angle right here?
Right angle.
It's a right angle. Skew lines. Any guesses what skew lines would look like?
Two lines.
Sort of look like that. Not like this though, right? That's what skew lines are. Are they ever going to intersect? No. But they're not parallel to each other, right? So you had a teacher probably in the past that told you parallel lines. They didn't have that word in there. They just said never intersect. Well, that wasn't true because these two lines don't intersect, but they're not parallel. All right? Examples in the room. What do I know about these two lines right here? They're parallel to each other. What do I know about this line and this line?
They're perpendicular.
Perpendicular. What do I know about this line and this line?
They're skew lines.
They're skew lines. Right. Write this down. Again, anything that's up here is your notes. Through a point not on the line, there's exactly one line. What's that symbol mean? Parallel to the given line. So what this is saying is, I have line H right here, and I have point A. How many lines in our world go through A and are parallel to line H? 2? 1. There's only one. Watch what happens. Watch this is this is my great creativity here. See that line? That's magic. Draw that picture with it. Through any line or through any point not on the line, there's exactly one line that's parallel to the original line.
I just wanted to tell you that you spelled it wrong.
Yeah,
No, I didn't. I spelled it that way because I was being lazy.
Yeah, I was gonna say that, but I knew Evan would say something.
He always picks out any
I already
mistake.
yelled at, so I was like, I just.
I haven't yelled at anybody all day.
It's gonna be Curtis tonight.
Technically,
I know.
you know, like, this morning,
I know it.
like, at the beginning, I think you like,
This morning.
Oh yeah, I did yell at him. 'Cause
For
he
what?
lied to me about
Oh,
those
yeah.
posters and
Oh,
everything.
What
He
did
sure
you-
acted like he knew it, didn't
You
he?
didn't ask.
Yeah, you didn't tell us.
Yeah, yeah, he did. What?
Yeah, he did.
Ooh, you make me yell.
You didn't tell me.
Yeah.
I wasn't
Okay, you
there.
tell everybody.
I just have.
Or you could be like me and just go to and ask.
I have to remember that with Caleb, I got to tell him separately. So like
Yeah.
when we get to the assignment, I'll say, "This is the assignment page." You'll have to go.
I had.
Not this year. I don't have to. I might do it
Next year.
5 or 6 years from now. If I'm just completely tired of it.
I'll drop out before I take this
What?
class twice.
What? They better get to do your work.
So exactly one line. Next one. Everybody got that? Oops. Oh, I forgot this.
What is that?
Those two arrows. Put those arrows on there. What's it? Guess what it tells us about those two lines? Tells us that they are parallel. Tells that's the symbol for parallel in a picture. So that tells us that they are parallel.
Sit to read this. What?
Yeah. Cool answer is.
So that tells us those symbols that put little arrows. Some books, I don't know. Some books will just do this and have little arrows like that. Other ones will have them colored in. So you just have to know either one of them means that those two lines are parallel. If there's other lines, and we want to show that they're parallel, but they're not parallel to those two, then we put like the double arrow on. Same as with the arcs or the little tick marks or anything else. Next. Another posh that says almost the same thing except, what's that symbol mean? Perpendicular. Through a point not on a line, there's exactly one line that's perpendicular to the given line. So if I'm trying to draw something perpendicular from line H going through A, how many lines are there in this world that I could draw? One. That's what that's going to show. One. That's the only line in the whole world that's perpendicular to line H. At that goes through point A. Look, Evan, I spelled through wrong.
I was gonna say that.
I just wanted to point it out before you pointed it out. Look, I spelled one wrong also. Making me look. Next. Don't write any of this down, just follow along.
Okay.
Well, I take that back. You might want to write this. Draw this picture. Just draw it real quick. This line is called a transversal. These two lines are called your coplanar lines. So just draw a picture real quick. And this is the part that's the main idea here. You got to know what a transversal is. So if Curtis holds his arm up in the air, wait. His arm would be the transversal for my two coplanar lines. And all a transversal is a line that intersects one or more coplanar lines. All right, it's just a line that intersects those other lines. Does that make sense? How many angles are formed when I have two coplanar lines and one transversal? 8. Somebody name this bottom green line for me.
Line B.
Line B. How about this one? Line A.
Line D.
Line D is the transversal. Tell me something you know about any angles in this picture. Which one? So one has to be congruent to 3 because they're vertical angles. Give me something else.
Angle 1 is something that's right angle 2.
Angle 1 and angle 2, these two right here, have to add up to 180. You still know all that stuff, right? Are the vertical angles down here? Yeah, that's something that we're going to get to as we go. Right. Special pairs of angles. You already got this picture drawn. All you really got to do now for these next 4 slides is write this part down. Special pairs of angles. Special pairs of angles that are formed by coplanar lines with a transversal. The first ones are called corresponding angles. Corresponding angles. And I'm going to try to explain corresponding angles to you before I tell you which ones are corresponding. So just write down corresponding angles, then we're going to put which ones they are in this picture. If I got my 2 lines here, all right? Hold your arm up for me again, Curtis. Curtis is my transversal. To make corresponding angles, if I shove the 2 lines together, don't fold them or anything else, you just shove them together, smash them together. The angles that lay over top of each other will be corresponding angles. So if I shove line A down on top of line B, don't fold it, just shove it down. Angle 1 is going to lay on top of which angle? Angle 5. Angle 2 is going to lay on top of which angle? Angle 6. Don't fold it, right? Angle 4 is going to lay on top of angle 7. Angle 3 is going to lay on top of angle 8. Guess what those are called? Corresponding angles. 1 and 5 are corresponding angles. 2 and 6 are corresponding angles. 3 and 8 are corresponding. 4 and 7 are corresponding. corresponding angles. Somebody read this top line right here to me.
Angle 1, angle 5.
Angle 1 and angle 5 are corresponding angles.
Hold on 1 second.
The same picture is going to be on the next slide, but it's going to be, so you got that picture drawn there somewhere on your paper. This goes with that picture, the next one's going to go with that picture, next one's going to go with that picture, so on, so on, so on.
Keep going. I'll do it.
You're going to what?
Never mind.
Alternate interior angles. Which angles do you think are interior angles on this picture?
3 and 5.
All of these inside here, right? All those inside are the interior angles. Which ones are alternate interior then? Those aren't even the interior angles. Which ones are interior angles? 4, 3, 5, and 6. Which ones do you think are alternate interior angles?
1, 2, 7, 8. 5, 3, 4, 6.
5 and 3, 4, and 6. The ones that sort of jump corner to corner, they're on or alternate sides like, those are the alternate interior angles. Now, as I put this up here, 4 and 6, 3 and 5. If you might want to write this down for alternate interior angles with this, form a Z. If you trace angle 4 and angle 6, that's angle 4, that's angle 6. What did I just form? A Z. Those are alternate interior angles. So if you trace them, they're going to form a Z. Now, if this picture was turned the other way, it wouldn't form a Z, it'd form a what?
An N.
Like an N. Alright? If it was some other crazy one, it might form something that looks like a lightning bolt or something. But it's all basically the same thing. So alternate interior angles. Why are they called alternate interior angles? They're on the interior and they're on alternate corners. Alright? They switch sides. They jump over the transversal and go to different corners. Next one, alternate exterior angles, same picture. Somebody tell me which ones you think are alternate exterior angles.
1 and 8.
1 and 8, 7 and 2. Good. 1 and 8, 7 and 2. Alternate exterior angles. Ready to get caught up?
Okay. Want to hear a joke?
No.
What?
Okay. Alright. So cows make milk, right? Where they drink? You didn't hear the joke.
I've seen that. The what?
Ruin the joke.
What'd he say?
You gotta lead up to it more than that. You're
So
not.
cows make milk, where do they drink?
I saw on Facebook everybody said,
Yeah, he's not leading
Except for
up to it
water.
enough. You gotta put some more to preface.
how do you not know the cows felt, well, the cows
Right here, right here.
Alternate exterior angles. So you got corresponding angles, you got alternate interior angles, you got alternate exterior angles. All those different pairs. Last one, consecutive interior angles. What do you think it means by consecutive interior angles?
Keeps going? Or like,
Sort of.
something like that?
Consecutive. Look at your angles. Which angles do you think are consecutive interior angles? Alternate was
4 and
like
5.
4 and 5.
3 and
Alright?
6.
4, 5, and 3 and 6. Because they're, instead of jumping over the transversal, they're on the same side. Now, what I call these, what you might call them, just to help you out. It's like there are roommates. Because 4 and 5 are both right there inside together. There's nothing in between them. Remember when we called 2 and 3? What did we call 2 and 3? We said that they were neighbors, right? Because, and there's a wall between them. 4 and 5, no wall between them. So it's like they're in the same room. Consecutive interior angles. Corresponding angles. What I do with the lines to figure out which ones are corresponding? Smash them together. And the ones that lay over top of each other. Alternate interior, jump corner to corner. Form a Z if you trace them both. Alternate exterior, jump corner to corner on the outside. Consecutive interior, the ones that are inside, both on the same side. Alright, you still have, don't write this down, you still have vertical angles, you still have linear pairs supplementary. We talked about that a couple minutes ago, right? Name me a pair of vertical angles in that picture.
1 and 3.
1 and 3.
4 and 2, 5, 8, 6, 6.
Name me a pair of supplementary angles.
2 and 3, 4 and 3, 5
4 and 3, 5 and 6, so on, so on, so on. So you still have all that, but you also have all these other special pairs. Alright, write this down.
Jeez.
This is the key to everything that you learned today. So if you don't write this down, screw it up. Again, remember these are notes. Still, it's your responsibility in your postulates and theorems section to copy these down. We'll talk about that later. But these go in your notes. This is my interpretation of each of these postulates or theorems. And again, on the test, I still had a bunch of people writing stuff like this as a reason in the 2-column proof. Should you ever put theorem 3.1 as a reason? No. I don't care about the numbers. This right here is what you'd write down. If these lines are parallel, then corresponding angles must be congruent to each other. Now notice on each of these, what do you have to know before you can use any of these theorems? The lines are parallel. That's the if part, the hypothesis part. You gotta know that you have parallel lines, then you can use all this other stuff. Get back to Dan. See a smile on your face all the time, so that's not usually your smile. Do I smell bad? So you just don't lie. I know I smell bad. That was horrible.
Yeah, you smell pretty bad.
Not as bad as it.
When I took a shower this morning.
Don't lie. This is Wednesday.
You didn't take a shower since last Wednesday?
No, I said this is Wednesday.
Oh.
So Friday's when he takes a shower, but
Probably after
it's once a week.
You probably want to take showers after football games.
I take a shower every morning and night, so.
And what? Why do you take a shower every morning and night?
Because it's not like full practice in the morning. I gotta smell good, you know?
Okay, why do you take another shower at night?
I don't see how somebody
Is that
can take a
football
shower in the
practice?
morning. If I didn't take a shower in the
It
morning,
wakes me up. I use like a shower. in
I
cold
can
water.
take a shower. I usually.
my hair would it'd be like a grease ball. If I didn't take a shower in the morning. Didn't do it. Man. Alright, so on these theorems, if lines are parallel, so you got every one of them starts off with you knowing that the lines are parallel. If lines are parallel, corresponding angles have to be congruent. If lines are parallel, alternate interior angles have to be congruent. If lines are parallel, alternate exterior angles have to be congruent. The only one that's different, you might want to put a big asterisk beside this one. All the rest of these say congruent. The pairs of angles that you have are all congruent to each other. The consecutive angles say what? Supplementary. Remember, those are the roommates. So the roommates aren't equal to each other, they're supplementary to each other. What's supplementary mean again?
180 degrees.
They add up to 180, very good.
180.
They add up to 180.
I only got a little room left.
In their sheet of paper.
You did?
I just did the back.
I don't know.
There's no way.
He's just being an idiot.
Yeah, he just has it.
picture.
You should tell them to stop cutting throats.
Tell me a pair of angles in this picture that are congruent to each other. One and what? 3. Because they're vertical angles, right? Now let's use this. Find me a pair of corresponding angles. 1 and 5. What do we know about 1 and 5? They are congruent. If these lines are parallel, then we know that those two have to be congruent. Now, Chloe just told us that 1 and 3 were congruent. Well, what other angle has to be congruent to those? So we know all 4 of those angles are congruent if we're given a picture like this. Give me another pair of angles. Let's use alternate interior angles. Give me a pair of alternate interior angles. 4 and 6. So what do you know about angle 4 and angle 6? They're congruent. I gotta mark them different than the others. What else do you know?
3 and 5.
You got those.
2 and 7.
2 and 7 also have to have that same marking on them as 4 and 6, right? So if I give you one number, how many of these angles should you be able to find?
All of them.
All of them. Alright? And that's what we're going to do on the next slide.
Yeah.
Draw this picture and write down those numbers. Make sure you put the parallel on there again. You don't have to write the words, but what is line D called? Line D. What's it called?
Transversal. Good question. This is the last slide.
Another sheet of paper.
Oh, I don't want to make it too big, Tim.
Guaranteed next time we have a quiz, next class, it's going to be a quiz, and you're actually going to have to do it yourself.
Yeah, what?
It's going to look like this.
Friday?
One of them. Yep.
We had a quiz on Friday. That's a good way to start the Friday.
Nacho.
Red, white, did that.
Nacho.
Should be easy, right?
Line all.
Tell me an angle that we know in this picture.
112. Angle 8.
Angle 8. Give me another angle.
Angle 5.
Angle 5. What's the measure of angle 5?
112.
Write it in. So write in
What's that say
112 right there.
Very quick.
Find all the angles. Give me another angle that we know.
6.
Angle 6. How do we find it?
You
180 minus
subtract
12.
from 180 and it'd be 78.
No.
Huh? 68. 68. My bad.
So at angle 68. Now we give me another angle.
68.
Because those are what kind of angles?
Vertical.
Vertical angles. So those are the easy ones now.
Yep.
Now we got to find something up there.
1.
Angle 1. How can we find angle 1?
It's the same as angle 5.
It should be the same as angle 5 because those are corresponding angles, right? How about, before we do that, how about angle 3? What do we know about it?
This 112.
It should be, it's not corresponding, it's a alternate interior, right? So what is angle 1? 112?
There's 3 is vertical angle.
What's angle 5?
112.
112.
Then you got 2 is over here and it's 68.
Some of the stuff's
Life's all about curves.
62.
68. Did we find all the angles just given one of them?
Yep.
Yeah. Yeah. And it's all based on the fact that what do we have to know about those two lines?
Parallel.
We had to know that they're parallel to each other. Next one, write those, or draw this picture. Same picture, different numbers. Oops. This should say find all the angles and X. Give me an angle you know.
7.
Angle 7 is what?
115.
115, so we can put that in there. Give me another.
8.
Angle 8.
It'd be 65.
Where's angle 8?
I mean 6.
Angle 6. 65. Everybody agree with you this time? Give me another angle.
5.
What is that?
65. X plus 5. Right.
What about X plus 5?
115.
X plus 5 should be the same as what?
3.
Same as 6 and 5.
6.
Same as 6 and 5, right? Because So x plus 5, we could set up an equation where x plus 5 should equal what?
65.
65. How do I find that then? Subtract 5, what's x then? X equals 60. So that's part of our answer. Now, what's the measure of angle 3? What do you know about 5 and 3? What kind of angles are they? Not exterior.
Oh, they're, alternate interior.
Alternate interior. So what has to be true about them? They gotta be 65. They gotta be the same, right?
Yeah.
What do you know about 5 and 4? What kind of angles are they to each other?
Consecutive.
They're supplementary, consecutive interior. So what's angle 4 gotta be?
65. No, what,
115.
115. Now my picture is drawn wrong, isn't it? Don't go by that though. What other angle do we know?
2.
Angle 2 is how much?
115.
115, because those are vertical angles, right?
Yeah.
Can be in, what do we know about this angle up here?
It's 65.
65, isn't it? X is 60, but the whole angle is 65. Getting all this, Caleb? Yeah. We're into the easy stuff now, so you better pay attention.
Put this right here.
So that we don't have that. Draw this picture real quick. A little tougher.
All the,
Little tougher.
all of, flex, do we need those in?
Yeah, we'll throw them away because you still, supplementary, all that stuff, we'll use all year long, so.
So what do we?
Unless you got it all memorized.
But I don't wanna travel for it.
Just, maybe grab another folder and put your old notes in that old folder or something.
Where's that stuff at?
What's different about this one? Oops, I forgot to name one of my lines. I swear I named it. The red line is what kind of line? What's it called again?
Transversal.
Transversal. The blue line is a transversal also. So this time we have 2 transversals instead of just 1. Whenever you have this, this is where everybody wants to make sure they're listening closely because these are the problems I like, not those easy ones. When you have this, you can't look at that whole picture as one thing. What we need to do is come out here, draw off the 2 parallel lines, and pick one of the transversals to deal with. Which one you want to deal with first, the red or the blue? The red. So if we do the red, we have something that looks about like that, right? What's this angle right here? What number? 1. How about this one? 2, 3, 4. Now down here is where you got to be careful. What's this angle? 7. How about this angle?
Oh,
It's like those 2 together, isn't it?
19.
So we really don't have a name for that one. How about this one over here? What's it? 8. We don't have a name for that one because it's 5 and 6 together. So you got to be sort of careful when you're splitting this off. Did they tell us any of those angles?
No. Wait. No, what is it? Oh, yeah, 50.
So we know that this one right here is 50 degrees. If that's 50 degrees, can we find all the rest of these angles? Yeah. What's angle 1? Let's do an easy one. What's angle 4? 50 degrees. Alternate interior angles, right? What's angle 2?
50 degrees.
50 degrees. 7 was 50. What's angle 8 down here then?
50.
50. What's angle 1?
130.
What's angle 3?
130.
Now 5 and 6 together should be how much? 130, right? 9 and 10 together should be 130 also. But that doesn't really help us at the moment.
960.
If we split off the 2 green lines, the parallel lines, and this time we use the blue one as our transversal. We know angle 10 is 60. Angle 10 is right here, isn't it? Can we find all the rest of these angles?
Yeah.
What's angle 5 right here? Let's do it first.
Angle 5 is
60.
60.
What's
Yeah.
this angle in here? Angle 13. 60. What's this angle over here? 60. We could write some of these in over here, 60, 60. Angle 10 goes 60, 60. Could we find angle 12?
Yeah,
What is it?
120,
About angle 14.
120.
Again, because those have to add up to 180, right? Now, angle 6 wasn't in either one of our two pictures,
110.
and neither was 9. But if we look at this, how much is this whole thing right here from here to there?
180.
180. If this is 60, that's 50. Can we find that little part right there?
Yeah,
By doing what? Add them together and
70.
70? Everybody agree with that? 70?
Yeah,
How about angle 9 down here?
70.
70 also. Did we find every angle in that picture?
Yeah.
Right. On this. See how I want to do this. This page, the first page here, it's not a really difficult page, but the second page deals with parallel lines. I'll tell you what, do this. This is a page I for sure want you to do. If you do this page, I'll replace a missing grade or a missing assignment.
You don't have anything signed.
Then I'll give you extra credit points. I'll replace a missing homework grade with that one. The other thing, the other part that we're gonna do. Grab one of these, take it with you, bring it back next time, and I will add, I'm not doing a test redo this time, but if you do that, I'll add points to your test off of that. It's the exact same thing as this that we went over at the start of class. So all Evan had to do was remember from the start of class till he gets started on it, and then could he get these extra points. You'll see it real quick, Austin, so you can try to run that. Does everybody understand all three of those things?